Good.
Hello, hola.
Hi, buddy. How are you?
Good evening, sir. Hello, good evening.
Hey, very good evening. Green. Okay. Art system. Okay, and here we have MAC address, right? And this guy and stuff. And appearance change with 9 is fine, right? So we right. So this guy's IP address will be 1011, right? And MAC will be 200 also. Same for this guy's IP will be 102, MAC 300. This guy will be IP 103, MAC will be 400. This guy will be IP 4, 500, and this guy's IP. All done, and all the devices start R1, R2, R5, R4, R3, R2, and switch on, right? And by default on the switch one, we have a single MAC address table, right? And depend on the VLAN, we have a multiple MAC address table, right? So how we can check the multiple MAC address table? You just need to put the command show MAC address table at the count keyword, right? So based on this command, you can have a information about the how many MAC address table you have. At the same time, they will tell you how many MAC entry you have learned as a dynamic way, at the same time as static way. At the same time, this command is also going to show you what is the total capacity of the MAC address, right, for this switches. And you have one interface has the capability, right, to learn all this MAC address on a single interface. By default, you do have a ability to limit that thing, that we'll see later on. Okay. And if you want to change them, if you want to define the static MAC address, you need to define the MAC address table, and you need to define the command for the static keyword that we have seen yesterday. At the same time, we can define the aging time. So in an aging time, if you see, you can define the aging time, you can disable the aging time as well as by putting the 0, or minimum you will have a 10, right, 10 second, a maximum you can go this amount of time, right? And after that, for example, I want to define the 10 aging time 10 second, right? And you can define the VLAN as well as, if you want. If you don't define the any VLAN, by default it will take the global one. So the VLAN number 10 now, and show MAC address table aging time. So this is the 10. I haven't defined any keyword of the VLAN over there. If you're not going to define any keyword of VLAN, what happened? By default, it will go for the global aging time. Mic is on. All good. At the same time, we have seen that whenever the router will send a packet, right, or PC as well as, what happened first, it will perform the ART lookup, right? Oh, mic is on. Kali, mic on. So you can see that I have all this ARP information in my table. Now, try to understand one thing. To send a packet, listen to me very carefully. To send a packet on an Ethernet technology, to send a packet on an Ethernet technology, we need to know the Ethernet address. Destination Ethernet address you can call as a MAC address as well as, and the 48-bit address as well as. You can also call this guy as a, the layer 2 address. You can also call as a data link layer address, whatever the address you can call it, the name, and you can also call as a hardware address. You can call as a physical address, whatever the name you can give. So we need this information to send a packet to the on Ethernet technology. Ethernet in the sense this is the actually a family, guys, right? This Ethernet actually is a family. In this family, we have multiple one. We have a fast Ethernet, we have a Ethernet, we have a gig Ethernet, we have a 10 gig as well as we have a 100 gig as well as. So these are just fast Ethernet. We have Ethernet, we have 1 gig, we have 10 gig, we have. These are all Ethernet families, right? And to send a packet on the fast Ethernet, Ethernet 1 gig and 10 gig, we need to know the destination MAC. So whenever the PC will send a packet, right? Whenever the PC will send a packet to the different PC, what happened? First, it will perform the ARP lookup. Hey, do I have a ARP entry for the destination person? If you have, send the packet. If you don't have, generate the ARP request, right? Same case will happen in the router as well as. So whenever a router will send a request, right? Right now, can you see I don't have an entry. When I see the ping 10102, what happened? Debug ARP. Right? I'm sending a packet from the router number 1 to the router number 2, right? Ping 10102. Can you see that over there? One thing, I'm creating an incomplete entry. We have seen that we have a two types of entry in the ARP. One we have a complete entry, and one we have an incomplete entry, right? Complete entry means what? Now we have a MAC information. Incomplete entry means what? I'm waiting for the MAC address, right? I'm waiting for the reply packet. Guys, these are the small things. Just write on because you will not find in the books normally. Okay, if I'm not getting the reply packet, for how many seconds, for how long the ARP will maintain this entry, incomplete entry? Just for the 60 second, right? So I'm making an incomplete entry, and after that, what happened? I got the reply packet. Can you see that I've received? And now I will make this incomplete as a complete entry. In a complete entry, what happened? We will have a MAC information. So router one is sending the ARP request, right? And now if you see show ARP at the same time, show IP ARP. Now, first of all, in this one, let me take a screenshot. Right? Can you see the one difference over there, guys? Show ARP and show IPR. These two commands, what do you think? Shame? Is it identical? Understand the meaning. If I'm going to talk about the output on a IP protocol, if I'm talking about the output in the IP protocol, output will be shame. Either you can use the first command or either you can use the second command. Your output will be same. If the output will be same, then what's the reason to introduce show IPR and so are two different commands over there? Can you see that output is everything same, nothing is different over there except the age, right? Because this time is going on, keeps going on. The reason was, do you know this command This command will show you the information. I'm talking about the show IP ARP, right? This command will show you the ARP information, right? Only for the IP protocol. Whereas this command IP protocol, Apple Talk, DECnet, IPX, what are the different technology was there? So in an older time, we have this kind of protocol, right? Apple Talk, and it's not like we are not using the Apple Talk as well as on the some Apple devices is still going to use the Apple Talk, IPX, Internet Packet Exchange over there, DACnet. These are the same protocol like IPs over there, right? Before the IP, these are the protocols to exchange the information, not exchange the information, to carry the information. Like IP, how the IP is carrying. Our IP is carrying the source IP information, right? And destination IP information, same like that. So on the time, on the older time, we were using the this command, right? And this command is going to show you the all the information, IPs, and you have Apple Talk, DECnet, and IPX as well as. But so IP ARP is only going to show the information on the IP protocol. So this is the main difference between this command. But if you're going to use this command on the Cisco router, and this guy is going to use the same protocol IP only, so it doesn't matter if you're going to use this command or this command, both have the same output. In the first output, if you see the first line is saying that internet, right? Internet means what? This means the IP protocol. Second thing is what? It's an address. Address is talking about the IP address. IP address means what? It can be a own address as well as, or it can be a LAN address as well as. Then after that, we have age. Age we can call as a timer that always have a in minute, right? And if you see one thing over there in the age, right? This value is going to represent that there is no timer. It means that it's my own entry. And then after that, we have an age over there. This is my learn information. Can you see that? I'm learning this. This is the router number one, right? On a router number one, I'm learning this information 1 or 2. How many second ago? 0 minutes ago, right? 0 minutes what? Some amount of second, right? Maybe the 55 second or maybe the 50 second, right? And in the next part, if you see, it was learn. I learned this information on the router number one. It's a 1 minute ago. So this timer will be keep increasing, and I'm learning the MAC address of my neighbor, right? This is my neighbor MAC address. That is the router number 2 actually. This one on the router number 1. Through the which technology? The ARPA, right? The type was ARPA. ARPA is the Advanced Research Project Agency. It was a one project, right? It was a one group that introduced the concept of Ethernet technology and ARPA as well as ARP. It can be anything. I'll show you the types. We have a lots of types of the ARPA as well as. And I'm learning this information, right? On which interface? Interface 0/0. So it means that all this guy, it will send the ARP request to this person. It will send the ARP request to, reply to this person. It will send the ARP reply to this person, and it will send the ARP reply to this person. So all this entry 300 MAC address, the 400 MAC address, the 500 MAC address, and 600 MAC address. Where I'm learning all this MAC address, I'm learning all this MAC address on a single interface. So on a single router, right? I'll ping the 1 or 2 3 now. Send the ARP request 1 or 4 now. Send the ARP request and 1 or 5 now. Send the ARP request. So on a single entry, right? So ARP, can you see that on a single interface, I'm learning all this MAC addresses over there. Single interface. Sorry, ARP entry I'm learning. and they have a different MAC addresses over there, right? And which protocol I'm going to use? IP protocol. And for how many second or minutes this entry will be valid? This entry will be valid for 4 hours. That is called as a ARP timeout. And ARP tap is what? It's a ARPA. It can be a different technology as well as also you on an Ethernet media. We are going to use the ARPA. It can be different as well as it can be very, but normally you will face now it is ARPA only, right? The ARPA is just going to represent at the code. This is the code that is going to represent, okay, the technology we are going to use the Ethernet. It can be changed. This is also called as a encapsulation type. We have a multiple types of encapsulation as well as, but normally you have to learn this part. And for how many seconds I'm going to put this entry? For 4 hours. Which entry? I'm talking about the ARP entry, this entry. But this timer you can change as well as you just need to go on the router. And I said, okay, let me change the timer. I said the interface Ethernet 0/0. You are going to change the timer on a particular interface, right? So it means that if I'm going to modify the timer, take example, this is router number 1. If I'm going to modify the ARP timer of this interface, right, 3 hours, I can modify on this interface as a 2 hours, or I can define leave it this interface as a default. So these are 4 hours, 4 hours. So you changing your timeout, right, on a particular interface, I can define anything over there, right? I can say that 10 minutes as well as. Now have a look. Show ARP, show interface, Ethernet 0/0. It's 10 minutes, right? So this entry is only valid for the how many seconds? Just for the 10 minutes. एक मिनट रुकना भाई. मैंने second define कर दिया क्या? Oh, sorry, I define in the second, right? That's why it's flushing out or 1 minute. Sorry. I have to define in the second, right? So how do I call it this guy? I say that 1 hour 3600 second, right? I can define for the 1 hour. Show ARP, show interface Ethernet 0/0. It's 1 hour. Actually, I've defined the second. This is the this value is hour. This value is minute, and this value is second. All done. So this is how we can change the timeout as well as. But again, do you know one thing? The changing the ARP timeout, right? It's not recommendation first of all, but again, depend on the scenarios, we can change the timeout as well as. At the same time, if you want to define the static entry for the ARP as well as, you can define the static entry as the ARP and define the like what entry I can define. Okay, take example, I'm defining 107, right? This is the IP address 107. Okay, what is the MAC address of this guy? I'm just going to define the any MAC address AA BB 12CA 3211. And after that, which technology I'm going to use? I mean, which encapsulation default is what? ARPA for the Ethernet technology, right? You can use the different as well as you can use the SAP as well as you can use the SMTS as well as SNAP as well as SRP as well as and SRB. So these are the some technology. Like for example, SNAP is going to use for the FDI and token. Normally, right now we are not using, but again, I'm not 100% sure, right? Some IBM company has introduced the token again, not 100% sure, right? Token ring concept. So maybe they are using or not. I'm not 100% sure, right? But on Ethernet technology, you need to define the ARPA encapsulation protocol. You are not going to learn this part, right? For the different organization, we are going to use the different. I think so. Let me check the token ring as introduced by the IBM. Token ring. network introduce the yes, it's IBM 1984. Right, same way the HP has a own mechanism as a SAP, right, for the RTAP. The this is the IBM we have. This is for the SMDS, right? So different organization we have a different technology. These are the, like, we can call it like a, it's a propriety of the HP, they introduced by the HP, right? But on a Cisco you can use it, but again for the Ethernet we are going to use the ARPA only. And then I need to define the ARPA technology, right? And from which interface I need to define the interface 0/0. That's it. And okay, what happened? Bad ARP command interface may only be specified when the bridging IP. Okay. Show ARP, and you can see why the interface is not taking. What should we take, right? We don't have Ethernet 0/0. Bad ARP command interface may only be specified when the bridging IP. I know this is some kind of bug is happening, right? But this is the command that you can define the static entry as well. So you can see that this static entry has defined, or this is the bit that you can define the static entry on the router. I don't know what this kind of bug is happening. So normally it's not seen in the real devices, right? So no, I don't know why. So you can define the static entry as well. So again, right? Question is that in which case I need to define the static entry again, the server cases, right? If you have a server, so there you can define the static entry for that person, right? Otherwise, what happened if the router does not have a, the PC and our router does not have a ARP entry, it will do the unknown unicast flooding, right? That's not a good for the network. So again, right, depend on the platform by, for example, you can say the key law, we can reduce the unknown unicast flooding, or we can say that we can prevent the unknown unicast flooding as well as. See, by default, unknown unicast flooding is enabled, right? By default, unknown unicast flooding is happening when the MAC address, right, when the switch is not able to find the destination MAC in the MAC table, switch will do the unknown unicast flooding. You can prevent this thing as well. But again, this command, right, unknown unicast flooding preventing command is only works on the some specific device. Okay, if you see the some devices are there, unknown unicast flooding, Cisco, and nobody will ask you, right, this kind of question like on which device this is enabled. Okay, 1 minute, what's happening? Can you disable your mic? All right, you can see on this series of router you can disable it. And what's the command for disable this thing? You just need to go on the interface, and I need to block the unicast. Forget the multicast plugin, otherwise you will get confused right now, because multicast all has a separate network we have. Right now we are learning the technology of unicast, right? So this is a command to block the unicast. So this unicast means it's not like that we are blocking the unicast, we are blocking the unknown. This keyword unicast is not representing the unicast. It represent unknown unicast, not the unicast. Let me check this command is working on those devices or not, because normally this command is not working on some devices, right? Interface Ethernet 0/0 switch. Okay, this is my router, so there, let me do one thing, let me make this guy a switch. We can switch over there. Interface 0/0 switch port lock, it's not working. So this command is not going to work. But if somebody will ask you, right, this kind of question, somebody will ask, right, can I block the unknown unicast flooding on the network? Like, they will ask you the scenario question, like, Take example, there is a lots of anonymous flooding is happening in my network, right? Because someone has performed the attack on my switches side, and what happened whenever the normal PC is sending the traffic, right? The switches is doing the anonymous flooding. So in that case, what is solution is happening? You just say that, hey, we can block the anonymous flooding. And how do I block? We just need to go on the interface and define the switch could block unicast keyword. But normally what happen if you go for the higher level of the interview, like like tax support interview, like your Cisco and the big organization, right? I mean, like VMware, like that, they will ask you this kind of question. But if you go for the normally like a freshers level, they will not ask you like how to block the unknown gas flooding, right? They will just ask you what is unknown gas flooding. I have one good docs of the R. 1 minute. Give me 1 minute. Let me find the my. So you don't need to read the all the 56 pages. Okay. I just want to show you something else. So in that case, what I will revise will be also happen, and we can done with all the concept of the R as well as. So basically, what is the use of R? So the address resolution protocol features perform a required function in a IP routing. Like R finds the hardware address, we can call it the MAC address, right, of a host from its known IP addresses, right? ARP maintains a cache table that is called as a ARP table as well as in which MAC address are mapped with the IP address. He's talking about this table. Sure, right? So this information ARP maintains a cache table where the all information is present, and ARP is a part of all Cisco system that run on the IP. So we have this type of ARP, guys. We'll discuss this thing all the one. So we have only done with the what is ARP, right? We haven't covered this part, reverse ARP, serial link ARP, and inverse ARP. We'll see this thing in the DHCP classes as well as. Because if I'm going to take this class right now, this part, right, what is the reverse ARP, inverse ARP? So you will understand this part, but you cannot correlate with the technology, right? So if you want to read the more about the ARP, you can have a look at the RFC number 826. If you want a more information of that, right? But it's the whatever the information that I gave you, that's enough information of that, right? We have already covered the this header, right? The ARP message header in the second day of the class, if I'm not wrong. No, first day of the class, we have done with the ARP all the header tabs, right? So you can see the hardware length was there. What is the size of this guy? Then we have Ethernet technology, and one more thing, right? Many person about like they don't have any idea and they are making a mistake of this thing. What person are thinking, right? We just have a two types of code, right? Remember the two I told you that you can identify the packets, right, based on the code value, or that code is known as a operation code, or we can call it as a opcode values. How many code we have seen? ARP request, the code number one, and ARP reply, right? Remember the first day of the class. So we all have a ARP from 3 to 9. We have a ARP like opcode values that is reserved for the RARP and inverse ARP request and reply. So what poor people are thinking, okay, we just have only two ARP codes value, right? One and two. No, it's have a more than one as well as more than two as well as that is a 3 to 9 that is totally reserved for the different ARP process. ARP caching we have already seen, right? What is the ARP caching over there? ARP caching is a storing method of storing the network addresses and associated with the data link layer address in the memory, right? For a period of the time. Your ARP cache entry will be either dynamic and static. We have seen the static and dynamic entry both, how we can configure the static. For the static entry, you need to define them manually. And for this one, there is no timer, right? It kept in the cache table on a permanent basis. In which case I need to define the static entry. So this is the best one that I told you right in the server, because the static entry are the best for the device that have to communicate with the other device, usually in the same network on a regular basis, right? Normally the your FTP servers, right, and FTP servers, and what we can DHCP server. Normally what happens, the PCs are always communicating with that server, right, to access the file, to get the IP addresses. So for that thing, you can define the static entry. Dynamic entries are added by the Cisco software and kept for the period of time, and then it will be removed automatically. So static entry, you need to define the manually enter the IP address, and then you need to define the the MAC addresses and encapsulation type as well, as that we have seen the multiple types of encapsulation. Inverse app, I'm not going to talk about the reverse app, not even, right? Leave it right now. The SLRP is also not important right now. Can you see that this part? This one, that answer. ARPA, right? This one I'm talking about. The type ARPA is only for the which person? Ethernet technology. Whereas the frame relay has a frame relay, or SNAP has for the FDI and tokening. That this SNAP that we have seen, right? If you see the R1, right, the ARP entry we have defined, we can call it as a what I get the IP address 101.1.10, the MAC address CC, and this is the SNAP. So you can define the SNAP as well as for the FDI and tokening. But normally you will not find in the industry, right, the FDI and tokening. Maybe if you go for the IBM and they are the older network, you can get the tokening as well as they have a whenever you go for the design of the perspective, then you will see that, okay, what is the problem is happening this kind of topology, or what is the problem is happening this kind of I'm just trying to clear the all the concept of the ARP right now. So sir, ARPI and ARP is a different. ARPA is a technology access, ARP is a protocol. Okay, now the thing is that how we can the remove the ARP table, or we can say the ARP cache as well as. So there is a two ways, right? Not two ways, we can say that we have multiple ways. We can put the clear ARP cache over there, and what happened, they will remove the all entry. So what entry they will remove? All the entry that is learned by the dynamic, right? All the ARP cache. You can see the command as well as I can simply remove the all the ARP that is associated with the IP addresses. I can remove all the ARP entry that is belong to the on which interfaces, right? Because this command is going to do what? I'll 1 minute, I'll explain each and everything. Copy this guy and paste it in the paint, then I'll explain you. Take example, we have three. If you put the clear ARP cache, can you see that I can easily put this enter over there, right? We have a carry return over there. This CR means carry return. If I'm going to put the enter, what happened? This command, right? Remove all ARP. Doesn't matter on which interface I'm learning. It does not matter on which interface I'm learning, right? What if you put the clear ARP cache, right? Take example 10101. So what this command is going to do? This command will remove the ARP, right, associated with the 101 IP. And if I'm going to put the clear ARP cache interface, the interface number I can put the Ethernet 0/0. So what happened? They will remove the ARP entry that I learned on each 0/0. And if you have VRF, forget this thing right now. Otherwise, you guys get confused, right? VRF is a totally different thing. VRF is like a VLAN, whereas the VLAN is going to do the logically define your MAC address, right, in the layer 2 network, whereas the VRF is going to logically define, create the routing table on the layer 3. At the same time, we have this ways, right? But if you see this command, right, if I'm going to remove this guy, it's not work sometimes, right? Show RP, if you see that I already have entry, I'm going to refresh my all entry. So if you want to remove all this entry, what we can do over there, we can go in the interface 0/0, shut it down, clap the interface, bounce the interface, just bounce the interface, and after that, if you see no shutdown, I don't have any entry because this is a static entry. It will be never removed, and I don't have any entries over there. All my dynamic entry will be flushed out. Just flap the interface, shut it down, and no shutdown. Bounce the interfaces. If you bounce the interfaces, all the ARP entry will be flushed out. Then after that, okay, we have seen this is the command actually that I gave you. The router was not working well, so ARP IP address. Then you can define the hardware address, encapsulation type, and you need to call the interface type. What interface you're going to map this ARP entry? This is the actual command. Okay, this interface type is optional over there, right? If you put or not put, it doesn't matter. It's optional. That's why he was took the command, right? The router took the command just because of the encapsulation is optional over there. It's not a bug, it's optional. It was not a bug, it was optional. Then after that, you can see that we have already seen the tab. By default is a 4 hours. Okay. Now this line, guys, make a note of this part. Guys, why I'm teaching you from this PDF, the R PDF, it means that if you're done with this PDF, your complete R will be done, right? Nothing is presented except this R, except this one. So this information is not there in the book. So I will upload this PDF as well as, okay, if you want to have a look in this PDF, you can have a look as well as. But I'm not done with the complete R. We have a lots of things about this. So we have almost 3 hours more lecture on the ARP as well as. So whatever the things that we have discussed, that's enough information for the next 1 week of the classes. So if your network is of frequent changes to catch entries, change the default to the sorted time, right? So in which case I need to reduce the timeout whenever your network has a frequent change. You can define the value of 0 in the ARP timeout, right? Means that entries are never cleared out from the cache as well as. The default is what? This one. So 0 means what? You are going to make a infinite over there. Leave me the proxy ARP right now. I'm not interested in the proxy ARP. Okay, there's a global instance. Bring the ARP cache we have already done, right? And we can also use the interface number as well as. Verifying the ARP, now have a look the information, right? So interface, you can also have a look, right? Based on this command, you can see the what is the time, what is happening, and which encapsulation I'm going to use. I show interface command, right? And you can see the difference now. Can you see that? So ARP, right? He was showing the information about what? Internet protocol. That's the IP, Apple Talk as well as. It can be a DECnet as well as, right? And so IPR, that's only going to show you the IP's information. Okay, and no need to have a look on the so process CPU. If you want to see that, you can see that like how many process the router took, the how many CPU router took whenever they are generating the ARP request, right? So you can check right through the this kind of so process CPU. But again, as for the CCNP label, I'm telling you, I'm not going to recommend it you though to just have a look, right? to see the what's process in CPU is happening, right? As per the CCNP level, until unless you are not a CCA student, right? Leave it right this part. But if you want to look up, this is the command to check, right, what are the CPU processes happening by the R cache. It will not show you the R cache, it will show you the all information. You just need to input the include keyword, and you can include the only ARP entry, right? Otherwise, it will show you the all information like a TCP timer, boot P, right? ARP input, logout, BGP open, BGP router, BGP scanner. They have a different CPUs, right? This is a different process that router you utilize. Then after that, we have all this entry. Okay, this is enough. This, don't look up this part. This is the higher level. Okay. So if you now look this information, I'll save this PDF. You just need to have look on the till 25 pages. That's it. Don't go beyond that one. Otherwise, you will never understand. This is the very high level things like monitoring and maintaining the ARP information. This is the very high level. So don't go for this one. This is the enough information for that. And this amount of information, is not present in a book. So if you want to make a note, you can make a note as well as. What happened to you? What happened? All clear, guys. Ask me any question now about the ARP, non-recast flooding, and MAC address. I'm done for the this three things now. I'm done with the show ARP. Sorry, ARP concept. I'm done with your ARP. I'm done with your MAC. I'm done with your MAC address table. I'm done with your aging time. Right. I'm done with your what we call basic LAN, like hub switches, right, and bridges concept as well as. That's it. If you have any question from this one, you can ask me. Guys, any questions, anyone?
No law.
Hey. No. So guys, till this today I'm done because I came to my family, family house. So leave it for today. I will do the tomorrow as well as okay. I was planning to cancel the rest, but I took the just. I think let's complete the art. So not at present. Please save the Google Drive link for the previous class video. My mail at so Satish. Okay, Satish, do one thing. Just ping me on this number because it's not possible to mail you. So you can do one thing. Just ping me on this number 9509. Okay, come on. 950-950-1035. I will just mention your name, right, and batch timing. I will add you in the group, right, WhatsApp group, and from where you can get all the drive link and everything. I will say the drive link again over there. And if you have any questions, right, please make a WhatsApp call. Only WhatsApp call, please.
Law.
I don't have the WhatsApp number, sir, because
Yeah.
I have called that number. It is only coming on that mobile only. I don't have any WhatsApp number of
I
yours.
have WhatsApp पे वो ये WhatsApp पे
I
number
had
है.
shared me that. Can you share